So the problem I chose to do was to sine x cos y equals 1. The reason why I chose this problem in particular was to use right here, because it's confusing when you're going down the path and using product rule and chain rule and forgetting that some negatives have to be and some don't. So basically, when you start off, you're going to want to use a product rule to find and chain rule within the product rule. So it's product rule and chain to find 2 cosine x times cosine y. This is like your u prime and then your u and then your v. Sorry, I got that confused. V u prime, u and then u prime and then v prime. So that's what you get when you plug it into the product rule stuff. And then you do subtract or minus 2 sine x times sine y. And then since you also use chain rule, you do dy over dx, which is equal to 0. Because when you find a derivative, when you're using a implicit differentiation, that just becomes 0. Cancels out, and then after this, you pull these apart. And so then you get 2 cosine x plus cosine y over sine x sine y, because you move this. I want to move this to the other side of the equal sign, because I don't want this entire thing right here to the other side, because I want it to become positive, and then I can multiply and divide it back onto the other side, so then it'll stay positive. It's a little bit extra work, but I just wanted to be positive. So then when you do 2 sine x sine y over regular sine y dy over dx. After you do that, you should end up with dy over dx, which equals 2 cosine times cosine y over 2 sine times 2 y. You can also use trig identities after this to find it to be dy over dx equals to 2, no, it is cotangent 2 over 2. I think that's how those work, but I'm not entirely sure about trig identities. So that's another thing that's why I chose this problem, because it also incorporates trig identities, and I'm not really too sure on how to do those. That's it. Yeah. Peace.